Ladies and gentlemen, welcome to this session of treating previous question paper. This is term 2, and we know that in grade 11 for the academic year 2024, they have introduced internal resistance in grade 11. So for term 2, it means that this video will be used by the grade 11. Then when we go to term 3, where the grade 12s are starting with their electric circuits, then they will also join and use this video, meaning that this video is meant for grade 11 and 12, treating electric circuits with internal resistance. Don't forget, ladies and gentlemen, if you haven't subscribed to this channel, make sure that you press the subscribe button, hit the notification button, and support this channel. Please also comment and give us feedback if these lessons are productive and they are assisting you. Okay, we are going to treat a previous question paper. Question number 4. This question paper consists of many electric circuits for internal resistance. It was taken from a document that is called The Last Push. So let us read the question. You can see that on your screen, the question is appearing. So we are going to treat it. Read it as it appears on your screen. It says that a battery with an internal resistance of 1 ohms. A battery with an internal resistance of 1 ohms. An unknown EMF is connected in a circuit as shown below, as you can see in your screen. A high resistance voltmeter V is connected across the battery A1 and A2. Represent ammeter of negligible resistance. Okay, let us just go to the question straight. We know that if a battery has got an EMF, which is the voltage that is in the battery, the maximum energy that is supplied by a battery, when we plug in the battery and that battery starts to work, it is not going to be able to distribute its maximum energy. Some of its energy is going to be lost in the form of heat because of internal resistance. So as a learner, you need to be conscious of that. Take note that we are not just only treating questions. There is a full video which is teaching electricity content with internal resistance. So if you don't understand the content of what we'll be doing, please make sure that you go and search for the video that teaches internal resistance as a content for you to understand how it works. So now let us go to question number 1. As it appears on your screen, it says state Ohm's law in words. I'm not going to dwell in definition, but it says Ohm's law states that the potential difference across the conductor is directly proportional to the current in the conductor at constant temperature. Okay, I want to write it. I'm going to make it pop on your screen. It is popping now. Okay, thank you. Let us go to the calculation, which is 4.2. We start with the calculation, which is 4.2. Okay. It says calculate the resistor, calculate the reading on ammeter A1. Calculate the reading on ammeter A1. I can just draw that upper part of the circuit. It is like this, the upper part of the circuit. It is like this. Then here we have A1. That's what we have. I've just represented the upper part only. They want us to calculate the what? The current in this circuit. Are we together? So what's going to happen according to the video that you saw, which was teaching content? Current is going to move through this wire, then current is going to be divided. Current is going to be splitted. Remember that parallel connection is a current divider. The current is going to be splitted. Then current is going to move to the upper resistor, and another amount of current is going to move to the lower resistor proportionally. This is 8 ohms and this one is 16 ohms. So current is going to be divided proportional, but we can see that this resistor has got 16 ohms, this one has got 8 ohms. Remember that at constant temperature, current is inversely proportional to resistance, which means that when current increase, resistance decrease. So for this one of 8 ohms, we are going to have a high amount of current compared to this one of 16 ohms. This one of 16 ohms is going to have a lesser amount of current. But what I like, according to the interpretation of electric circuits, is that another amount of current, current is going to be splitted. Another amount is going to go through the 8 ohms resistor. Another amount of current is going to go through the 16 ohms resistor. But when it comes to this point, that current is going to come together and pass through A1. That's what you need to understand, that it is like water which is flowing in a water pipe. Water is going to flow, and another amount of water is going to be splitted up. Another amount of water is going to move down. Then when it reaches this point, the amount of water is going to be collected. Then it passes through this point. So it means that what is going to pass through A1 is when we add what is passing through 8 ohms resistor and 16 ohms resistor. That is the interpretation. So we need to calculate the current at 16 ohms, the current at 8 ohms, we add them. It means that is the current that is going to pass through A1. I hope all were together. I repeat, if you haven't subscribed to this channel, make sure that you subscribe. Also, tell someone about this channel, especially kids around Limpopo, around Wembe, around Skukune, around Waterberg. Please make sure that you tell people about this channel. Thank you very much. Okay, let us treat our question. We can see, according to the given information, that the 8 ohms resistor, have got 0.5 current. As you can see, that they say with each S closed, the current passing through 8 ohms resistor is 0.5 amperes. So we have the current that is passing through here. We have the current that is passing through here. So what we need is to calculate the current that is passing at 16 ohms resistor. Then how do we go about it? There are two ways in which we can calculate the current that is passing through the 16 ohms resistor. We can use proportionality, or we can use just electric circuit formulas, calculations. Okay, let me show you how we calculate this one. Let me show you. Okay, let's start to treat our question. So the first method, let me show you the first method. The first method, we know that the voltage under parallel connection is equal. If resistors are connected parallel, they've got equal voltage, but their current is different. You need to take note of that. So if we can calculate the voltage of this 8 ohms resistor, it is equal to the voltage that is in the 16 ohms resistor. Then we'll be able to calculate the current that is here. Then we add them. We know that that will be the current that will pass at A1. As I told you that it's like water that is pleated, is going to move through the upper part and the lower part, but when it reaches this point, it's going to be collected. Okay, so let us just calculate the voltage here. Voltage is equal to current multiplied by resistance. Then we have the current there is 0,5. The resistance is 8. Then 0,5 multiplied by 8 is going to give us 4 volts. It means the voltage that is here, it is 4. Then what do? We can calculate the current that is here since we know the voltage. Why are we calculating the voltage for here and we want to use it here? Is because we know from theory that the resistors that are connected in parallel, they have equal voltage. But take note, their current is not the same. Then let us calculate the current that is here. Current is going to give us V over R. Then we substitute. Current is equal to voltage 4 over 16. Whereby 4 over 16, it is going to give us 0,25. 0,25. Is it 0,25? I'm with my learners here. Can you punch on the calculator and we confirm? It's 0,25, right? Thank you very much. 0,25 amperes. Then we have the current for this 16 ohms resistor. Then it means for A1, the current that is passing at A1, it is going to be what? It is going to be 0,25 plus 0,5, which will give us 0,75 amperes. Then we got it. So this is one of the methods that we can use for that question. Some of the people may not even use electricity. They may use proportionality. What does it mean? Let us look at the ratio between these two resistors. The ratio can say 16 is to 8. From the grade 9 maths that I am teaching, I know that the proportions, they need to be written in their simplest form. So we need to find the highest common factor here. Then we divide by 8. We can divide by 8. We divide by 8. Then we're going to have 1 is to 2. So this is the what? This is the proportionality. So what does it mean when it comes to this proportionality? Although it is going to be the opposite. The proportionality of this one, the problem with it, it must be the opposite. The one with a 1 must have a high, high current. Then the one with a 2 must have low current. So we are given, what are we given? We are given the current for the 0,5, the one of a 1. Are we together? Then since we have 0,5, it means if this one is 2, 1 is to 2, right? But it is in the opposite side. It means we're not going to multiply by 2. We are going to divide by 2 because this proportionality is opposite. As we know that current is inversely proportional to the resistance. So this time we divide by 2, which will give us 0,25. That's how we deal with proportionality. Although the proportionality for electricity, it is in the opposite manner. Okay, let us quickly do the other one. I usually advise kids to use this method that I demonstrated on the board rather than the proportionality because you may make a mistake. The second question, it says that if device R deliver power of 12 watts, calculate the reading on ammeter A2. If device R deliver power which is equals to 12 watts, Calculate the reading on ammeter A2. Calculate the reading on ammeter A2. What can we do about this one? What can we do about this question? If we want, we can calculate the resistance that is at R. Can calculate the resistance that is at R. We can see that R is parallel with the electric cord that we have at the top. Take note of this. R is not parallel to 8 and 16 just like that. We need to calculate RP for 8 and 16. We add it with 20. Then everything in total is parallel to R. Not just 8 and 16 only. You understand? You understand? Yes. Learners, I told you that when we talk about parallel, we don't focus on the resistors, but we focus on an electric wire. So this resistor is parallel to this electrical wire, all of it, not only these two resistors. It means this resistor is parallel to this one plus this one. You understand? So that's how we need to calculate that one. So how do we calculate? Here, all we need to do is to calculate current. We need to calculate the current that is at R. When we calculate current that is at R, so we have calculated this current that is A2, because the current that is going to pass through here, it is going to be the same as the one which is going to be read in this electrical cord where they've put this ammeter. You understand? So all we need to do is to calculate the current that is at resistor R, which is delivering 12 watts. You understand? So how do we go about it? We have got our formula. Our formula which says power is equals to VI. Our formula is power is equals to VI, potential difference multiplied by current. That is the first formula for what? For power. So how will we solve the current here? It is straightforward. All we need here to solve current is the voltage. We need the voltage that is going to pass through this resistor. So how do we calculate the voltage that is passing through this resistor? We know that this resistor is parallel to everything that is at the top. I repeat, this resistor R is not only parallel to these two, it is parallel to everything which is at the top. It is parallel to this one, it is parallel to this RP, and it is also parallel to this one, meaning that we are going to make this one to be RP, we make it one resistor, and we add it with this one. You understand? We're going to make this one to be series with this one. That's what we need. Then we know the total current that is passing through here. The total current that is passing through here, it is the current that we calculated at A1. You understand? Because I said current is going to be splitted and it is going to be collected here. So what do we do? Let us start by calculating RP for these two, so that will make them one thing. Then we add with this one, we calculate their voltage. We know that the voltage that is in this electrical cord is equal to the voltage that is here. Notice when we're calculating the voltage for these two, we got 4, but that 4 is not going to work here because there is this resistor which is also along this electrical cord. You understand? So we need to be careful. So what do we do? Let us calculate RP. RP is equals to, you know, my formula, which is straightforward. 1 over R1 plus 1 over R2 to the power minus 1. This is the formula for RP. This is the formula which I think it simplifies everything and it is straightforward. Then RP is equals to 1 over 8 plus 1 over 16 to the power minus 1. It is straightforward. Then what do we get for RP? Our RP is going to be 1 over 8 plus 1 over 16. 1 over 16 to the power minus 1. Then what do we get? We get 5 5,33333. Can put a dot here to show that these threes, they are continuing. So our parallel resistance here, RP, is equal to 5,33. Then what do? If you check the lesson, when we calculate for RP, it's like we make two resistors to become one resistor. When we calculate RP, this is what we did. When we calculate for RP, this is what we did. This one is what is RP. That's what we mean. This is an interpretation where I'm changing the second. The reason I'm changing the second is to demonstrate to you that we had two resistors. Now we have merged them to become one resistor, which we call RP. You understand? So now we have RP, and our RP is 5,33. Can you see? This RP is in series with this 20 ohms resistor. And what I like is that we know the current that is passing through here. We've already calculated it. It is the same current that is going to pass through here. You know that the resistors that are in series, they've got equal current. When we say calculate RP, RP means to fuse resistors to become one resistor. RP means to fuse resistors to become one resistor. That's what RP means. Then let us move forward. Now, it means the resistance in this line, it is going to be R, which is equal to 5,33 plus 20, which is going to give us 25,33. That is 25,33 ohms. So it means the resistance that is here is 25,33. Then we want to calculate the what? The potential difference that is here. Why are we focusing here? Is because there is nothing that we can do here. There is nothing that we can do with this one. All we need to do is to use the theory, to try and find the information about this one. If we get the potential difference that is here, because this electrical cord is parallel to this one, we know that they've got equal voltage. So we're just going to calculate the what? The voltage that is here. Then we are going to use it here because they are parallel. They've got equal voltage. Then what do we do? What do we do now? What do we do now? Simple. We calculate the voltage. V is equals to I current multiplied by resistance. Then the voltage. What is the current there? The current we've already calculated it is 0,75 multiplied by total resistance, which is 25,33. Then what is the voltage? 0,75 multiplied by 25,33. Then we are going to get 18,9975. I will not do the rounding off before I reach to the final answer. You do not round off before you reach the final answer. So this is the voltage that we have. This is the voltage that we have. So since we got this voltage, what do we do this time around? What do we do this time around? We are going to use this formula of power. We are going to use this formula of power. Let me write this at the top. Power, how do we calculate power? Power is equals to the velocity multiplied, the voltage multiplied by current. Hey, I'm using V and I'm saying velocity. I apologize for that. We are used to always dealing with velocity. Remember, we're in term 2, grade 11, they're doing electric circuits, and they've just introduced internal resistance for electric circuits of grade 11. So that's what we're doing. But yourself, the grade 12s, you will use the very same video in term 3 when you start with your electric circuits. Okay, so power, we're given the power. The power here is 12 watts. Then we're given the voltage. We just calculated the voltage. It's 18,9975. Then we multiply it by current. Then we're going to divide by 18,9975. We divide both sides by 18,9975. Are we together? Then what do we do? Then we say 12, we divide 12 by 18,9975. So now we got it. The current that we got, it means current is equals to 0,63 amperes. So the current that we got for this one is 0,63 amperes. So we are happy. This is our answer. It means the current that is going to be read at A2 is 0,63 amperes. And this makes us happy because we know if we want to calculate the total current for this electrical circuit, we're going to add the current that is here and the current that is here. We're going to get the total current for the whole circuit because we no longer have any circuits there. So that's how we were supposed to do that one. Okay, let us move to the last equation, 4.4. I hope you can see. Let me explain how we got it. We started by calculating RP. We started by calculating RP for the two resistors that were here. We fused them to make them one resistor, which will be in series with the 20 ohms resistor. And then we added them because they are in series. Then we calculated the voltage, and we already know the current that was 8A1. So it made it easy for us to calculate the voltage. Then we calculated the voltage. Then we use the voltage here using the formula of power, which says that power is equal to IR. Then simple as ABC, then we got our current. So that's how we are supposed to treat questions like this. Then now, let us do 4.4, our last question. 4.4, our last question for this electric circuit. Let me not erase it, maybe I'll still need to use it. Okay, question 4.4, it says that calculate the reading on the voltmeter when switch S is open. Calculate the reading on the voltmeter when switch S is open. Remember, switch S is here. They say calculate the reading on the voltmeter when switch S is open. Okay, it needs a bit of interpretation. When switch S is open, it means here we're going to have the wires which are on air. And from theory, we know that if the wires are not attached, current is not going to flow. Current does not flow in an incomplete circuit. If the circuit is incomplete, current is unable to flow. So it means that since there is nothing that is flowing here, even the voltage will not be operating in the whole circuit. It means this circuit is not working when the switch is open. So what does it mean? It means what are we going to do? We're going to the question says calculate the voltmeter reading. So if we calculate this V voltmeter reading, the one which is here, when this thing is not working, from theory we know that terminal voltage is equals to EMF if the switch is open. Terminal voltage is equals to EMF if the switch is open. It means that since the switch is open, there is nothing which is flowing here. There is nothing that is flowing in this electric circuit. It means that the question wants us to calculate EMF. They just use terminologies to confuse us so that we don't get the correct answer. So the question want us to calculate the EMF. The question want us to calculate the EMF. Terminal voltage is equals to EMF. This is terminal voltage. Terminal voltage is equals to EMF when the switch is open. If there is nothing that is flowing, it means that when it is like this, we are not going to have any amount of energy being lost in the form of heat. This is like having a battery like this, and this is the nipple of a battery. Then you take a what? You take a voltmeter like that. This is a battery. This is a battery. You take a voltmeter and you measure the voltage that is inside the battery directly from the battery. Nothing is going to be lost. What is written here? The EMF. If the EMF is 12, even the reading on your voltmeter you're going to get 12 because there is no resistance there. There is nothing that is going to be lost. Terminal voltage is equals to EMF if the switch is opened. So that's what we are going to do. We are going to do the same things. We are going to do the same things. Okay, so this scenario is the same as this. So we're calculating EMF. The question wants us to calculate EMF. So we're going to say, use the formula of EMF. EMF is equals to I. The EMF is going to be I. Then RR. That's how we are supposed to deal with that one. Let us read through the question. It says the battery with an internal resistance of 1 ohms. 1 ohms. So we know that this lowercase r, it is only 1 ohms. What we may need to do is to calculate the total resistance, because we know that the current that is here, we just calculated it. We just calculated the current of this part, and then we may need to calculate what? We may need to calculate not the voltage, the resistance that is here. We need to calculate the resistance that is there. We know that the current that is at R, I can say IR is equals to 0.63 amperes. Right? The power is 12 watts. So how do we calculate the resistance? From deriving the formulas of power. Why are we calculating resistance? We want to calculate total resistance so that we can come and substitute it here to calculate our EMF. So how do we go about it? We are going to calculate the resistance using power. We're going to say, I love using only one formula. P is equals to VI. Then if we want to calculate the resistance, what do we do? Power is equals to, what is the voltage? How do we write the formula for voltage? Voltage is equals to current multiplied by resistance. Then we multiply by I. Here we did not do anything. We just substituted the voltage with the current multiplied by resistance from the general formula. You know that. Then power is going to be equals to, then when we multiply everything throughout, we're going to get I squared R, meaning that this is our formula for calculating what? Our resistance. I usually tell kids not to crack their head by trying to cram the formula. Knowing this formula, P is equals to VI alone, you will be able to calculate, to derive different formulas from it. Myself, I don't know this formula, but I know I can produce it using this formula. I only know this one, so the others, I just produce them myself. That's why I had to use this step to get. So if I want to calculate my current, I'm going to say power is 12. Then the current, I just calculated it, is 0.63. We square it, then R. Then we need to divide by 0,63 square. 0,63 square. Then let us see what we get. Resistance is equals to what? Resistance is equals to what? Resistance is equals to 12 divided by 0,63. We square it. And the answer that we get 30,23. That is 30,23 ohms. So we know our resistance now. This resistance is 30,23. So since we have got that resistance, now we want to calculate total resistance so that we can go and substitute in our formula. Total resistance. What is the total resistance? Total resistance, we can see that they are parallel, right? They are parallel. So it means we're going to calculate for RP. RP is equals to 1 over R1 plus R2 to the power negative 1. The power negative 1. Then what do we do? RP is equals to 1 over 30,23 plus 1 over 25,33. Then to the power negative 1. Then RP. Notice that this formula of to the power negative 1, it is a formula which is straightforward. You just punch on the calculator and get the answer without having to struggle with anything. We're going to have 1 over 30,23 plus 1 over 25,33. Then to the power minus 1. Then what do we get? Our answer is 13,78. I will not round it before I reach the final answer. Our answer is 13,78. That is our RP. And this RP is the total parallel resistor. This is our total resistance. Then we come to our formula. EMF is equals to I R plus R. Then we say EMF is equals to total current. Total current for this circuit, we add the current that is here plus the current that is there. How do we go about that? We just say I tot is equals to 0,63 plus 0,75. Can you see that? Then I tot is equals to, that is our I tot, as I've just said. I tot is equals to 1,38. We go and substitute it. 1,38 total external resistance, that is 13,78. We've already calculated it, plus 1 the internal resistance that we're given. Then we punch in the calculator to get our EMF. EMF is equals to 1,38 multiplied by 13,76 plus 1, as you can see. Then our answer for the EMF is 20,4 volts. That is our EMF. I forgot to write the SI unit, the voltage, as you can see. So that's how you should treat that question. Ladies and gentlemen, we are reaching the end of our lesson. Those who stay at Malamlele, you are invited for our extra lessons, which are very affordable at Gumbani Village. I've posted my contact for more information. Thank you. The end.